Lesson 13, volume. So volume is just a continuation of area. So let's look at this first one, volume of a triangular prism. If you look, there's the triangle on the end, right? We know the formula for a triangle, uh, half times base times height. Okay, but now what we're doing is, you think about this, there's a bunch of triangles just stacked on top of each other, so then we have to multiply it by the length to get the volume. So if you look at the formula, a half base times height times L, or base times height times length divided by 2. Okay, we'll use the second formula in this case. So let's just look at this triangle. So there's our base. Our base is 15. Yeah, we've labeled it. Our height is h, and our length is 12. And all you do is plug it into the formula. 15 times 8 times 12, all divided by 2. So 1,440 divided by 2, 720 centimeters. Now, this is not area. This is volume. So centimeters cubed. Because it's think about it this way. It's centimeters times centimeters times centimeters. Yeah, centimeters cubed. So volume is cubed all the time. Okay. So another example here. We have our base of 10, we have our height of 10, and we have our length of 25. Plug it in the formula. B times H times L divided by 2. So 10 times 10 times 25 is 2,500. Divided by 2 is 1,250. Centimeters cubed. Don't forget, volume is cubed. Okay. Second page, let's try volume of a rectangular prism. Now, this one's really quite easy because we knew what the area of a rectangle was. It was just length times width. Now all we do is we multiply it by the height. So we have length times width and height. Just multiply them all together. So let's look at an example here. So length is 7, height is 4, and width is 2. Now, this is another one where you can change the order of this. If you want to change these letters around, like if this wanted to be an H and this wanted to be a W and this wanted to be something else, it doesn't make any difference. When you're multiplying, the order doesn't matter. So plug it in, 7 times 2 times 4. We end up with 56 centimeters cubed. Okay, look, another example here. Height is h, length is 3, width is 5. And again, you could have those rearranged, right? You could have the width as the length and the length as the width. It wouldn't make any difference, right? You change it around because you're multiplying. So 3 times 5 times 8, just plug it in. We end up with 120 cubic inches or inches cubed. Okay. Third page, let's talk about the volume of a cube, right? Interesting about a cube, remember all the sides are the same length. So you could either go length times width times height, still works. Or you could go S times S times S or S cubed. Right? There's variations on that formula. What's more important is the overall concept, that you know that it's a cube, all the sides are the same, you're multiplying them all together. Okay, so here's a cube, 6 centimeters by 6 centimeters by 6 centimeters. So 6 times 6 times 6, or 216 centimeters cubed. If you did it with the other formula, as in S cubed, you go 6 cubed, plug that into your calculator, 216. You get the exact same answer. So it really doesn't matter which way you do it. Okay, bottom one here. 4, 4, and 4. They're all 4s in this case. So let's do the shortened version. Volume equals S cubed. So 4 cubed. So 4 times 4 times 4 is 64 cubic inches or inches cubed. Okay. Page 4, let's talk about a cylinder. Now a cylinder is just like, we did the area of a circle, pi r squared. There it is right there, pi r squared. And all we're doing is we're timesing by the height. So basically it's a bunch of circles stacked on top of each other. That's where we get the formula for. And cylinders can be upright or they can be left to right. It doesn't matter. It can be tipped on its side, like this one here. So what we got here is we have a cylinder. The height is 4 centimeters. Now this one gives us the radius already. Very nice. So the radius is 2. So we can use the formula. So pi times 2 squared times 4, right? Pi r squared h. Plug it in. What do we got to do first? We got to do that square first. So 4 squared is 4. So 4 times pi, right, gives us 50.26. We're going to round to 1 decimal place. So we, looking at the 2, so we look to the right, we see the 6. Since it's 5 or greater, we take that 2 and round it up to a 3. So then it's 50.3 cubic centimeters. Okay, another cylinder here. Oh, look at this one. They're trying to trick us. 10 centimeters is the diameter. It's not the radius. So the first thing you got to do is you got to take that diameter and change it to radius. So divided by 2, you end up with 5 centimeters. Now we can plug it into the formula. So volume equals pi r squared h. The radius is 5, so 5 squared. The height is 12. What do we do first? We do that 5 squared first. So pi times 25 times 12, we end up with 942.47. Round to 1 decimal place. So rounding to the 4 there. So we looked 1 to the right, it's a 7. So that means, since it's greater than 5, that 4 is going to round up to a 5. So we end up with 942.5 cubic centimeters. Okay. Page 5, volume of a cone. And again, these formulas are given to you. You don't have to memorize any of these formulas. You'll always get a formula sheet with that on there. Okay, so this one, here's the volume, 1/3 times pi r squared h, or pi r squared h divided by 3. It's the same thing. When you multiply by 1/3, it's the same as dividing by 3. It makes no difference. So let's do an example. So right away, yeah, we got the radius, 5.7. Yeah, we got the height. That's internal height. That's different because there's something called slant height, which we can talk about in a different lesson. So we plug in the numbers. The radius is 5.7, so 5.7 squared. The height is 12. Again, you got to do the math. You got to do this exponent first. So 5.7 squared, 32.49. Multiply everything together, then divide by 3. And we end up with, and you'll see this like 1224.84 in the dot, dot, dot. Keep it in your calculator because don't round until the end. Because if you round too early, your answer will be off. So if you round at the end, then you're fine. So keep that in your calculator and divide by 3. So you end up with 408.28. Again, one decimal place. That's the standard for this stuff. We're going to look at the 2. That's where we want to round to. So we look one to the right. We see it's an 8. It's greater than 5. So we're going to take that 2 and round it up to a 3. So we end up with 408.3 cubic centimeters. Okay. Let's look at another cone here. This one, what's that 8 inches? That is the diameter. We want the radius, so we got to divide by 2 first. So 8 divided by 2 is 4. So our radius is 4. Now we can do the question. Write down the formula, plug everything in. So the radius is 4. The height is 12. Plug it in. We got to do that 4 squared first, which is 16. So we end up with pi times 16 times 12, all divided by 3. So again, 603.1857 dot, dot, dot. That's just the number in your calculator. Keep it in there. Divide by 3. You end up with 201.06. We're going to round to one decimal place. So we're looking at the 0. So then we look to the 6 and we see, oh, it's greater than 5 or greater. Then we've got to take that 0 and round it up to a 1. So we end up with 201.1 cubic inches. Okay. 6th page. Let's talk about the volume of a sphere or hemisphere. So a sphere, right, is the total ball. The hemisphere is half of that. So there's the formula. 4 times pi times r cubed divided by 3, or 4/3 pi r cubed, right? Either one works. So I'm going to use the first one. So we look at our sphere. We have a radius of 14. It's nice. It's already done that for us. So 4 times pi times r cubed. We're plugging in r, which is 14. So we're going to cube that first. So 4 times pi times 2744. And there's our big number, 34,000 and change. Wow. Divided by 3. We end up with 11,494.04. Again, we're going to round. So if it says round to one decimal place, so let's look at this one here. So we're rounding the 0 here. So we look at the 4. Now, since it's less than 5, you keep that value the same. And a lot of people will be just tempted to drop the 0. But if it says to round to one decimal place, you better have one decimal place there. So if it's 0.0, you write 0.0. All right. Now, this is kind of a tricky one, this last one here. This is a hemisphere. So basically, if you were to find the volume of a sphere, you could just take it and cut it in half. Whatever it happens to be, cut it in half. That's the end result because that's where we want half of it. Okay, now we look at 78 feet here. Well, that's the diameter. So the first thing we got to do is we got to change the diameter to radius. So 78 divided by 2 is 39 feet. Now we can use the formula. 4 times pi times r cubed divided by 3. So we plug in the 39. So we do all the work here. Oh, 39 cubed times pi times 4. Big number. Keep it in your calculator. Divided by 3 equals, oh, even a big number here. Keep it in your calculator because we still have to do one last step. We have to divide by 2 because we only want half of the sphere. So we have number here divided by 2. We end up with 124,237.42. Round to one decimal place. So we're looking at the 4. We look to the right. We see it's a 2. It's less than 4 or less. So we keep that 4 the same. So our final volume in this case is 124,237.4 cubic feet. And don't forget your units. Units are incredibly important. Okay, so now you can work on the practice for lesson 13 on volume.